In college algebra, we started logarithmic functions. So the whole idea here is, what if we don't know an exponent, but yet we know the result? Now, you guys all know what x would have to be, I hope. 4 squared, right? Well, the logarithm idea, because sometimes you can't always do that in your head, but the logarithm idea says we're going to take the log base 4 of 16, it's like backwards math, equals x. And you can type that into the calculator. So let's look. You have a whole button for this. Control 10x. See how it says log right above 10x where it's red? And if I go base 4, 16, it should give me 2. Like when you hit enter, it's giving you an exponent. It's very backwards thinking, all right? So back to this. By the way, that is not log 4 to the 16th. That is not what that's saying, all right? It's a base. So you write the 4 a little bit lower, and then 16 should be right in line with the log, all right? Those are not the same thing. That's a funny looking arrow. There we go. So not the same thing. This bold sentence right here, this is the key, or what I just wrote right there with the arrow. All right, that bold sentence right there is the key to memorizing and working through this. So at the very bottom, you see example 1, and it says write each equation in its exponential form. This is saying rearrange. Do not solve. You are welcome to solve, but that is not what I'm grading. I'm just grading you rearranging it. So on part A, I read this as the base. This is the exponent. And my word for the number all by itself in the normal looking equation is answer. That doesn't always make sense because that's not always the x, but that's what goes through my brain. So I write that in exponent form as 5 to the 2nd power equals x. So in that scenario, x is 25. But that's not what I'm looking for. I'm looking for this. So let's try again. The base is b. The exponent is 3. The answer is 64, the number all by itself. All right? Wouldn't that be 4 in that case? 4 to the 3rd power is 64. All right, let's do another one. 3 to the y power equals 7. This one right here is the whole reason why we have this lesson, because I don't think anyone knows what 3 to the y power equals 7 is. But the log function can definitely tell us. All right, moving on. Let's get to number 2. And now we're going in reverse. We're writing it in log form. Rearrange. Do not solve. So this is our base. Of course, this is our exponent. And answer. All right, so log, for some reason it stopped recording. Now we're going again. So let's try again. Log 12 of x, so the base and the answer go right next to each other, equals the exponent. On part B, it is log b of 8 equals 3. The very last one, there's a shortcut, but let's do it the same way. Log e of 9 equals y. And if you write that, you get full credit. No worries there. But there's something else that happens when you take the log of e. Log of e is using the natural base. There's a shortcut on your calculator, and that's the ln button. So that is, let's go to the calculator. If you press Control EX, see how it says ln right above it? It's called the natural log. I have no idea why it types it ln and not nl, but it's just understood that it's natural log. All right. Oh, we don't need that. So another way to write this is ln 9 equals y. That's acceptable, or that's acceptable. Doesn't matter to me. That's great, and that is great. All right, on number 3, it says evaluate. Let's solve. I do not mind if you type it into the calculator. But if you like a challenge, try and do it in your head. Set it equal to a variable. And we know that 2 to a certain power equals 16. It's 4. The next one, set it equal to a variable. 3 to what power equals 9? 2. Last one is very tricky to do in your head. 25 to what power equals 5? Well, we know square root of 25 equals 5. Isn't that a half power? Z, in that case, is 1/2, or 0.5. That's what your calculator gives you. So feel free to type it in. If you can't do it in your head, no worries. I'm not grading work on these on number 3. All right? Okay, moving on. These also you could do in your head or type in, and this would be 7 to what power equals 7? And that's just a 1, right? B looks kind of weird, but think about it for a minute. 5 to what power is 1? 0. But type it in if you want. These last two are very weird properties. We know that b to the x equals b to the x, to the x. And that is what that property is telling us. Another way to think about it is, since I have log b of b, it's like they cancel out and x equals x. They don't really cancel out, but you're welcome to do that. You'll get the right answer. Same on this. Log b of x equals log b of x. And likewise, the b's cancel out and x equals x. Once again, that doesn't really happen, but you'll get it right if you think like that. So let's give it a shot. If I set it equal to x, 4 to the x equals 4 to the 5th. Or just cross out the 4's, and we know 5. Let's try another one. Log base 6 of 9 equals, oops, that should be an x. Got ahead of myself. Equals log base 6 of 9. X must be 9. Or just cross out the 6's and you have 9 left. All right. Hope that made sense. See y'all later. Bye.